Good morning. It's June 1st. My goodness, June 1st. So good to see all of you here. I feel like the attendance of these videos are dropping, that's for sure. Instead of having like 20 at the beginning. Morning. Now we only have 11. What's going on? People still sleeping here? Oh my goodness. All right, it's June 1st. Let's talk about a couple things. You probably all know that school has sort of reopened, but I feel like for me, it's so much easier for me to do all the online streams at home because I have my entire setup here. So I don't really foresee myself going into the school at this point. Luckily for our division, it's great for that because we're not like required to do that. However, there's going to be some days that it's going to be more tricky because my wife is also a teacher. She's required to be at work. That means my kids are going to be at home with just me. So some of the days might be a little bit trickier than others because that means that I would have to watch those two kids all by myself while I do the live stream. So I'll see how that goes. But I feel like now we're sort of slowly wrapping up. I know we have this unit in the middle of this unit, but I feel like it's we're sort of coming to a close to our chemistry class. I think last time we talked about the types of solutions. I did get a chance to take pictures of the answer key to most of the work booklet for this unit. So if you're still wondering where that is, it's going to be here. So if this is your OneNote, and if you click on the work booklet, which I think you guys have found already. Oops, not there, not there. Go to the work booklet answer key. Here's the thing. When I uploaded these, I just basically selected all the pictures and then uploaded. I realized that the order is actually backwards. So if you scroll all the way to the bottom, this is actually the first page or the closest one to it. So if I can find my work booklet. I don't know what page this is because it's just all like tens at the top. But like this stuff, I didn't include a work answer key to it because it's just your notes. You can totally go into the notes and fill that in. It's just like definitions and all. But starting with the solubility table, so this is where I started, but because this is where you have more of the calculation questions. But if you do have any questions about the other ones, just let me know. But I feel like because the other ones are just, from your notes and all of that, it's, you can just go into your notes to find it. But again, your answer key is sort of in backwards order. So if you scroll to the bottom, it's actually the first one. And then as you scroll up, it moves in. I was trying to fix it, but then the more I fix it, the more it sort of screws up because like right now it just kind of covers the image, right? So that's the thing. But that's just a little heads up in doing that. But we'll continue on with your solutions calculations today, and hopefully you guys all got a chance to enjoy the nice weather this past weekend, and also had the chance to try one of these questions of solubility curve. So let's just kind of review about what we did last time. Last time we talked about dissociation, which is like if you were to dissolve something into water, a solid, it's going to dissociate. And what that means is that that solid NaCl, right? Remember we wrote this and we wrote the state as an S. This is going to dissociate. That means it's going to break up into its ions. This is so important because next year in grade 12, you guys are going to run a lab of this. And it's like your big project where you have to figure out what's inside your test tube. You might have heard of from your friends. It's their first project and it's all about solubility. Basically what you're going to do is that you're going to get 12 different test tubes, and in these test tubes, I'm not going to tell you what they are. You have to figure them out based on different experiments and tests that you run. So it is imperative for you to understand, like, when you dissolve something into solution, what happens? And if I were to dissolve this NaCl into this test tube, what exactly is found here? And what's found here is that you're going to have this dissociated ion that's here, and then you're also going to have this dissociated ion that's there as well. So that's something that That you have to understand. My dog is barking. I'm just gonna check if there's someone at the door. That's why. Just give me a second. I feel like um, there is somebody at the door. That's okay. We'll let it be. I don't know why my dog is barking. Anyways, yeah. So that's dissociation, and that's what happens when you dissolve something, and what it looks like in solution is what we call the solvation process, and we talked about this last time, and it's about like, hey, what happens to that solid salt or solid substance that you put into water because it just disappeared, right? It doesn't just vanish, it dissolved or dissociated. So what does that look like, right? So initially, if we were to draw something like this, you're going to have your H2O molecule. So you're going to have H, one O and two H's like this. This is all into your water. So if you were to draw this out, this is what you're going to have. And remember, we talked about those polarity, about the partial charges, right? So oxygen has that partial negative charge, that sign that you're wondering, that's delta. That's for electronegativity. So when we have this designation, negativity, let me just spell this first. This is delta. This is the lowercase Greek letter delta. And that means that it has that partial negative charge. Because that you have that partial negative charge, you have more electrons hovering around this oxygen. That's what that means. If you have this negative, that means that hydrogen is going to have that absence of negative one, so that you're going to have a partial positive charge hovering around hydrogen atoms here. Okay, this is important because that tells you what's going to happen when you dissolve things, right? So this is the story. So I'm just going to tell you like what exactly is happening. So then the next step is that you're going to dissolve. Let's say that we're going to dissolve this into the solution. So initially you're going to have this solid CaCl2. This is still solid. And what it looks like is that you're going to have Ca and two chlorines that's attached, right? And along with that, you're still going to have your H2Os. So this is your H2O right here, and your negative and positive charges right here. So then as this continues to dissolve, it's going to break this down. This is what you're going to have is that you're going to have this oxygen, which has a negative charge, positive charges around your hydrogen. And you see that this CaCl2 is going to start to dissociate. Let me change colors again. So if you look at this calcium chloride, right, you know that this side, it has a 2 plus charge, and this one has a -1 charge, right, or 1 negative charge. This is what happens when you break this down and dissolve, right? So you're going to have this, and you're going to have 2Cl1 minus. So that's what's going to look like inside your solution. So as this goes into your solution, this is going to start breaking it down to 2 plus of a calcium, and then your chlorines are going to break it into chlorine negatives. So since this is a positive ion of calcium, this is naturally going to sort of gravitate towards the oxygen negative side, right? And since the chlorine is negative, it's going to go towards the positive hydrogen side, right? Notice that they're opposite charges. So as this continues, then you don't need to use all of the different spaces. I'll just leave this up. But as this continues, you're gonna have a lot of water. All these H's, all the positive H's are gonna surround your negative chlorines. All the negative chlorines are gonna be here, and then all of the negative oxygens are going to surround your positive ions. So notice that your charges are all like this, right? And then this is negative, positive, negative, positive, like that. Okay, that's what they call the solvation process. So that's what happens when you dissolve something. And if we were to fill in more water molecules, you notice that the oxygen is the negative side, that's going to combine and pair up with the positives. Oh, so that's what they call the solvation process, or when you dissolve a ionic substance. Okay, yeah. So this one is about ionic substance. Let's talk about what a covalent substance would be. So here it says dissolving a covalent substance. Covalent substance. So some things like sugar is a covalent molecule. That means that their electrons are shared. Your sugar molecule is like this, a C6H12O6, right? That's a big sugar sort of molecule. It looks like a ring shape if we were to draw like this. So this covalent structure of sugar actually will not sort of dissociate. It's not going to break down into like C plus or H plus or O negative. It's not. This is going to be big clump of sugar molecule. So if we were to look at a sugar molecule, you're going to put sugar in here. So let's put sugar in here into your beaker of water. And your sugar is going to be this big clump of molecule. And the cool thing about this sugar molecule is that some regions of this molecule is going to be negative and some of it is going to be positive. So let's just say like this is your positives and this is negative side. Okay, that's your sugar molecule. So how does that dissolve? How will a covalent substance dissolve? Well, it's still going to do the same thing except that it's not going to dissociate. So what's going to happen is that your sugar molecule, because it has those polar sides, so you're going to have some regions that's going to be positive. What's going to happen? What's going to be sort of attached near the positive side? Well, if this is positive, the negative oxygen of water is going to go near it. So this oxygen is going to go hover around this positive side, whereas the other side of your, not this one, the negative one, right here, you're going to have your positive hydrogens that's going to be hovering it. So why we do this is that this is to get you to think about opposite charges and also the movement of the electrons. So this solvation process of a covalent substance is really sugar doesn't dissociate into its ions. It's just that your water will orient itself that you have opposite charges. Okay, so this is your sugar molecule. Does that make sense about how this is working out for how sugar is dissolved? Right, so you have your positive side of hydrogen pairing up with the negative side of water pairing up with the positive side. That's what makes water unique, because it has this ability of having two sides, right? Because water is a polar molecule. It has two sides, so it can actually sort of pair up into and dissolve this different substances. Okay, usually in class, I would have you guys actually do this story, cut these molecules up, and then sort of situate around based on the charges. But that's, in a nutshell, what solvation process is. Okay, so let me know in the chat if you have any questions, if this makes sense. What I would ask you is that, can you do this? Can you explain to somebody what the solvation process is? And are you able to draw out that your charges are going to be opposite when they dissolve? Okay, have that practice. Make sure you do see that, because as we move into grade 12 chemistry, it is very important for you guys to really visualize what's happening with the charges, because that in itself is really what chemistry is about. It's the different movement of the electrons and the opposite charges, right? So that's that. Let me know in the chat. And then we also talked about unsaturated and saturated and supersaturated solutions, and we used the elevator as an analogy, right? If this elevator has a maximum capacity of 15 people, that's a bad color, right? Having below is unsaturated, having at the maximum capacity is saturated, and having more is supersaturated. And we move this into looking at this solubility curve. This is about the different substances that can be dissolved in different temperatures. So you notice that in this solubility curve, it depends on two things, right? How much stuff you can dissolve and also the temperature. And you can see that in this trend is that as you increase in temperature, you can dissolve more stuff, right? So when you're doing a question about this, I think we can go through a couple of the questions here. Which of the salts shown in the graph is the least soluble at 10 degrees? So if we look at 10 degrees, which one would be the least soluble, right? So here in this axis, this is the grams of solute dissolved into 100 grams of water. The lower it is, the less amount or the lower number of solutes you can dissolve, right? So you're gonna find which substance is the lowest, and you notice that it's this one, potassium chlorate. That's your answer. That's it, right? Number 2, which of the salts shown has the greatest increase in solubility as temperature increases from 30 degrees to 60 degrees? So really, you're looking at the greatest increase in solubility, the biggest sort of change, right? So which substance has that biggest increase or biggest like slope, right? The steepest slope. And you notice that this one from here to there is a pretty steep slope. So potassium nitrate is your answer. So like those ones are good sort of conceptual questions about that. But let's do like a calculation question. So if we were to say like, let's look at number 11. 30 grams of potassium chloride are dissolved in 100 milliliters of water at 45 degrees. Let me see if I can change colors so then you don't get mixed up here. Let's use green. So we're at 45 degrees around here. 45 degrees. And you're looking at potassium chloride. So I don't care about any of these other ones. I'm just looking at this line, potassium chloride. And I have dissolved about 35, or 30 grams, sorry, 30 grams here, right here. Am I saturated, unsaturated, or supersaturated? Well, you can see that I'm underneath this line, so I'm still unsaturated. I can dissolve more stuff. But the question is asking how many additional grams of potassium chloride are needed to make the solution saturated at 80 degrees. At 80 degrees. So we're moving from 45, right here at 30 grams, to 80 degrees. Why did I put 85 here? 80 degrees, right here. So then you're starting off at 30 grams, and you want to make this saturated, right? So at the saturation point is at here. So how many grams do you need to saturate this? Well, if you go to the y-axis, it's 50 grams. So you need 50 grams. You started off at 30 grams. How many more do you have from 30 to 50? Well, you need 20 grams, right? So the answer is 20 grams to get to saturation point. So 20 grams is your answer. So that's really how you want to interpret this curve. I will let you guys work through this. The answers are all down here, so double check your answers after. But it is really important for you guys to practice this and try this out. Okay. Any questions about this? I'm gonna have a drink of water. You guys should totally like my shirt. I don't know if you guys can see. Look, I'm wearing a avocado shirt, right? Just to give you an idea of the love of chemistry that I have. Next part, I'm gonna go through the molarity now. So we've done the saturation and reading the curve. Here's the next important part that you guys have. So if you want to follow along, I have this notes. But molarity is the next way of calculating and measuring. Okay, molarity is basically a unit of measurement, and what it is that it's defined as the number of moles dissolved in 1 liter of solution. Okay, so it's how many moles you have in 1 liter, of solution. So the equation for molarity is this. It's it's molarity is equal to moles over liter. I'm not even going to put the 1. I'm just going to put 1, or just put liter, as in it's per liter. So if you have 0.5 moles and you want to find the molarity, it's really just M is equal to 0.5 moles, and you assume that it is in 1 liter. So this, you assume 1 liter if the volume is not given. So what that really means is this. Let me see if I can make this window a little bit bigger. What that means is this. If you have 0.5 moles of a substance, right? And you don't know what the molarity is, right? You don't know what the concentration, like how much stuff is in that volume. Well, you can actually just assume that let's put this into 1 liter of water, right? If you were to divide, or if you're going to dissolve, I should say, 0.5 moles into 1 liter of water, essentially you're just calculating molarity. It's just 0.5 moles divided by 1 liter, which is 0.5 m. That's a unit for molarity, or molar, okay? So molarity can sometimes be denoted as C for concentration or M for molarity. Most of the time we're going to use molarity, okay? And or M for molarity. So for units for molarity is this. Because you're dividing moles per liter, these are your units. So you can have moles per liter, or in a shorthand form, you can have capitalized M for molarity. So sometimes when you work with solutions, you're going to see, especially in like acids and bases, you're going to see something like 6 molar of HCl. This means that you have 6 moles of HCl dissolved into 1 liter of water. That's what that means, okay? That's what molarity means. So here's an example. What is the molarity of a 5 liter solution that was made with 10 moles of KBr, potassium bromide, right? Again, molarity equation is number of moles divided by the liters. So you're just dividing this, right? So you have 10.0 moles, and then you have 5 liters, and then you divide this, you're gonna get 2, let's do 2.0 moles, or molar, or 2.0 moles per liter, or really shorthand 2.0 capitalized M. Notice that this is capitalized M. That is important for you to write. If you write 2.0 lowercase m like this, that is wrong, okay? I noticed that some of you guys, when you guys are answering questions, make sure that your elements are capitalized. So when you're doing your answers for your assignments, like if it's Na, it can't be like this. Or if it's like hydrogen, it cannot be H. That's wrong, right? Elements, those symbols, they're capitalized for a reason, and not capitalized also for a reason. Okay, make sure you have that. Another thing to add is that if you're doing scientific notation, I got some questions about this, is that how do I write this if I'm typing this out, right? How do I write this? So the way of writing this is that 6.0 times 10, and then you're going to use that little hat. So this is, if you look at number 6, right? If you do shift 6, this is that hat. This is to show that is to the power of, okay? That's how you want to write scientific notation if you're typing this out. All right. Any other questions about this? Let's try the other 2 examples. Example 2. A 250 ml solution is made with 0.5 moles of NaCl. What is the molarity of the solution? So molarity, again, is moles over liters, but because you're given a milliliters, you need to change this milliliter to liter. And you can change this by like this. Unit analysis times division bar, milliliters over liters. How many milliliters are in 1 liter? If you think about in metric system, 1,000 milliliters is in 1 liter. So you're going to cross out the milliliter. You're going to just really simply moving the decimal 3 times to the left to get 0.25 liters. Okay, Once you have that, then you can use this. So you're going to take out your moles, which is 0.5, divide it by 0.25, and then you should get 2.0 molar. I totally just did that in my head, but you're dividing by a quarter, you're multiplying by 4, so that should be it. Let me just double check the math before you guys get upset at me. Yeah, it's 2. What? Hold on a second. Why did I write 0.25 here? Oh wait, this is for this one. This is the answer. There we go. Yeah, so that's it. Not to get confused with that. If you have any questions, let me know in the chat. But this is molarity. I think it's not too bad of a calculation. You just have to know it's moles per liter. Let's try example 3. Now we're looking at the volume. So what would be the volume of a 2.00 molar solution made with this amount of moles? Okay, so now you're using the same equation. This is molarity, is moles per liter, but now you have to change this around because now you're trying to solve for volume, and you have to manipulate this, but it's really just cross multiply. So you're gonna use, if you fill this in, you're gonna have 2.0 molar is equal to 6.00 moles divided by liters, right? This is what you're trying to find. That's your volume. So you want to isolate that. I'm going to cross multiply this. So I'm going to have 2.0 times your volume, which is your liters, is equal to 6.00 times 1, if you put a 1 there. And then you're going to isolate for this one. So you're going to divide both sides by 2. So then, and then you're going to cross this out. And then you're going to have 6 divided by 2, which is 3.0, is equal to your liters. So really you have 3.0 liters. That's the volume that you have if you have 6 moles in a 2.0 molar solution. Okay, that's that. Now in example 4, you're looking at how many grams. So first, how many moles of CaCl2 will be used to make this solution? And then now you have to figure out for the grams. So you notice that because there's moles in your equation of molarity, like here, moles per liter, if you were to solve for moles, basically once you have solved for moles, you can solve for the grams, you can solve for the volume, you can solve for the molecules, right? So that's the next step. So let's just solve for the moles first. I'm going to plug all these numbers in. I have 0.5 of solution. So this is 0.500 liters is equal to 5.0 moles. Again, as you do a lot of these questions, don't just sort of look at the numbers and immediately substituting into the formula. I know it's very easy to do and it's really quick and most of the time it will work. But as we move into the next part about like making a solution and dilution, it is so important for you to visualize what exactly you're doing based on the question, because sometimes the wording of it will mess up how you calculate. This one is calculating for the moles, so I'm just substituting this and do the cross multiply. This one's easy, as in it's just straightforward. So I'm going to cross multiply all this, and I'm gonna get 2.5 moles of CaCl2. That's the answer. So that means that if I have a solution here, right here is my beaker and has a 5.0 molar solution, and right here it only has half a liter. In order to make that solution, I need 2.5 moles of CaCl2 in here. But again, well, I should stop saying again because I haven't said anything. But really, 2.5 moles means nothing, right? We don't know how much of it, how much to measure. So how about we calculate how much of that is in grams, right? And that's really using your next step of molar conversions. So I'm going to take that 2.5 moles of CaCl2. I'm going to convert this to grams, right? Something that you can weigh and make and measure. So I'm going to put moles at the bottom, grams at the top. Now we have to figure out the molar mass of this. So that's your molar mass. And I believe calcium is about 40 grams per mole. plus 2 times 35, so it's 40 plus 70, which is 110 grams for 1 mole. So you multiply this, so 2.5 times 110, you're going to have about 275 grams of CaCl2. What does that number mean? What does that answer mean? That means you're going to take 275 grams, and if you were to dissolve that, how much of this? If you dissolve this into 0.5 liters of water, you're going to have a concentration or molarity of this. Okay, so make sure you make sense out of these numbers. Okay, that's really what molarity is. You can also go backwards with example 5, but I'd rather have you guys try example 5 because the answer is given. But that's really what molarity is. It's really finding the concentration of this. Let me know if you have any questions, but I think I have another tutorial video of this. We're calculating molarity. If you ever get stuck, you can go back to that. But right now, I would really want you guys to work on these questions. You should be done all these ones. I really hope, crossing my fingers, that you have tried this. If you haven't tried this already, really do that because these are your calculation questions. And then do this one, and then start doing this one, this one, this one, this one, and this one. And then the next part is just dilution, so don't worry about it. So really it's just like one worksheet to do, 1.5, okay? And the answer key is posted. Again, there, it's in backwards, so answer key is here, answer key is there. But really give it a try. At some point this week, you guys are going to get another sort of assignment quiz for you guys to do on molarity and also your solubility questions with the graph. That's really it. And yeah, and then on Thursday, I'll talk about like lowering freezing point. We'll maybe make some ice cream. Maybe on, wait, not Thursday, Wednesday. Let me see. Do I have any meetings? No, I think Wednesday should be okay. So we can totally make some ice cream on Wednesday. I can show you why that happens. Next week we'll do dilutions, and that's all we're gonna do for chemistry grade 11. So really keep up with your work. Do these worksheets. Are there any questions? I can't believe it's June already. If any of you want to come in and meet with me one-on-one to do some tutoring, just let me know. That means that we would have to go through with the protocol of coming into the school, but that's appointment basis. So let me know with that. Send me an email, send me a message. But that's all I wanted to do. Make sure you guys keep up with your work, and that's about it. Okay. I will see you on Wednesday. If you want to make ice cream with me on Wednesday, make some ice, get some ice ready, have a small cup of milk, some sugar, and vanilla, okay? And 2 Ziploc bags and some newspaper. And that's what you need. So again, ice, get some ice ready, small cup of milk, sugar, vanilla extract, 2 Ziploc bags, 1 for the milk and then 1 for the ice, and then some newspaper or some paper to wrap it up as insulation. That'll be good if you can do that with me. But that's it. It'll be fun because you get to eat the ice cream after, and it's actually quite tasty. So I will see you on Wednesday. Take care, everybody. It's supposed to be really nice out. So bye.